Assalamualaikum warahmatullahi wabarakatuh and good day again. So I hope everyone in good health and also good spirit. So let's continue chapter 1, our second part of the chapter, which is lateral earth pressure. Okay, so we can see the application of lateral earth pressure from a retaining wall like this, L shape of retaining wall, trapezoidal shape of retaining wall. We can also implement or use the lateral pressure knowledge when we want to design or we want to have a deep excavation, especially dealing with embankment or basement and also tunnel. So what is lateral pressure? It is analysis or determination of pressure that soil exerts, especially in the horizontal direction. Compared to previous topic, we already learned about excavation, about uh, vertical stresses. However, in horizontal direction, it is much more easier if we address the soil action to the structure in terms of pressure. Okay, so there are three categories of earth pressure. Earth pressure at rest, active, and also passive. So what is lateral pressure at rest? Let's see the first condition. Okay, as we know that in one, let's say a soil element, we have a in situ stress. So for vertical direction, of course, we have a effective vertical stress. So like this, effective vertical stress. I hope you still remember how we define effective vertical stress is from the total stress minus the pore water pressure. So we can get the effective stress vertically. So if we can introduce a coefficient of earth pressure, K sub naught, K naught, so we can define the stress horizontal effectively. However, as we mentioned just now, we more interested to know lateral pressure rather than lateral stress. So we can define lateral pressure when we associate the vertical stress with the height and also the coefficient of earth pressure K naught into the pressure equations. So we can have pressure for total stress condition and we can have a pressure exerted by water to the soil. So we can see the gamma water or unit weight of water in here. So this gamma can be gamma bulk or gamma dry or gamma saturated, follows the condition of the soil that we having in the site. Okay, how the equation of pressure is defined? Okay, we can see here. So if you still remember the previous video, we have a example how to calculate the total stress, pore water pressure, effective stress, and plot the stress diagram. So this is initial session that we have before we go to Fathom and also simple 2-to-1 method. Okay, from here, if we know the gamma, we can define the vertical stress. Okay, so we can have a vertical stress here. But mentioned just now, in order to have a lateral stress or lateral pressure, so we have to introduce the K naught. K naught, the coefficient of lateral pressure. So how we define K naught? Okay, usually K naught is defined by using the K equal 1 minus sine internal friction angle, phi, sine phi, internal friction angle. So instead of only knowing the unit weight of the soil in previous, so now we have to get more data from site in order to understand how much the lateral pressure is acted on the soil. So if we know the angle friction, friction, so soil friction angle, so we can define the K naught and finally we can get the full calculation of lateral earth pressure. So P sub naught is lateral earth pressure at rest. Okay. When we already have the vertical stress, so each stress diagram, actually each level of soil, we can define their own pressure. So we can have a pressure here, pressure, another pressure here, and also pressure in the third level. But in ultimately, we can combine all the total pressure, and for ranking method, later on we will see the ranking method in active and passive condition. For ranking, they assume that the total pressure of the any soil is at third, one third from the total height from the base of soil that we analyze. So some around here, one third from the base, from the toe of the soil layer. Okay. So as long as we know the vertical stress, or this is vertical stress, or we know the unit weight gamma, unit weight of the soil, and knowing the height of the respective layer, we can get the pressure, because this is actually a equation of to get a area in a rectangular, triangular. So triangle. So if we assume this is a good triangle, like this one, water pressure showing a good triangle. So it is half times height, okay, height, one height, times the gamma h. So this is the width of the triangle is 70 kilopascal here. So it is actually consists of gamma times gamma water times height. So height here and height here, that's why height here and height here. So that's why in final equation of pressure, we got height in power of 2 times the coefficient of lateral pressure for the soil, times the gamma, times the 1/2, so we can get a pressure in soil. However, in water, we doesn't have 2 times any coefficient of lateral pressure, because the water itself is a pressure. So just pressure of water is 1/2 times gamma water times height in power of 2. Okay, so for the active and passive, so in previous is the rest condition. Now active and passive pressure. So let's say we have a sheet pile or retaining wall in here. Okay. So this is a retaining wall. Okay. So let's make it as a much more thicker. Okay. So this retaining wall is having active pressure from the higher portion of soil over here, and passive pressure from the lower portion of soil over in the next side. So usually in the lateral earth pressure, we interested to define where is the failure line. In the lateral earth pressure, we interested to define where is failure line. So for active, ranking method here, they define active pressure. The failure line is a sliding wedges, slide. So with the angle of 45 degree minus phi, the internal friction angle, divided by 2. So the angle of the sliding wedge for the failure line, this is the dotted line is failure line. In active pressure in Rankine is 45 degree minus phi divided by 2. Whereas for the passive pressure, the failure line is having a angle of 45 degree plus a phi divided by 2. So if you could see the big picture of active and passive pressure, so we can divide them into cohesionless soil condition with active and passive condition. Similarly, in cohesive soil with the active and passive condition. And one more thing is we can also have a embankment with a flat uh, ground condition, or either with a slightly we can have a angle in here, so it can have a beta angle, or sometimes also in Coulomb they opt as alpha angle, but usually in Rankine method we opt angle here is a beta angle, so means there is slight inclination in the embankment for the retaining wall. Okay. So okay, one more. As I mentioned before, P naught, previously P naught equal to 1 over 2 gamma height in power of 2 K naught. So in active, it will be substitute as Ka, and in passive, it will be substitute as Kp, coefficient of passive lateral earth pressure. So you can see here, in Rankine method and Coulomb method, they define the Ka in their own way, but mostly similar to each other, except for the condition with the beta angle, the slope with the inclination. But if they having a flat soil behind the retaining wall, or in the front of a retaining wall or pile sheet, sheet pile, so it only opt the Ka as similar. Ka is equal 1 minus sine phi, internal friction angle, divided by 1 plus sine phi, or sometimes also simplified as tangent in power of 2, 45 degree minus phi divided by 2. And Kp is the inverse of the Ka. Inverse of Ka, 1 over Ka. So Kp. So Ka sometimes can have a very simple condition if we have a flat, just a flat condition of soil. But Ka also can have a quite lengthy if we have a beta. But in general, we can see the pattern that Ka, all the Ka can be addressed. All the Ka can be addressed as tangent in power of 2, 45 degree minus the phi divided by 2, internal friction angle divided by 2. Okay. So for the Rankine, as I showed just now, so this is the pressure active. This is the definition equation for the active pressure, and then the Ka, two different condition. And for passive, the Kp is inverse to the Ka. In cohesive soil, in the cohesive soil, I think okay, this one. In the cohesive soil, compared to cohesionless soil, just now the P is quite simple, but in the cohesive soil, we have to consider the cohesion factor. So we can see the cohesion factor. We have to deduct the 2 times cohesion square root of K sub A, the coefficient of active. Similarly, for the passive earth pressure, instead of minus, now we have to plus the 2C square root K sub P, coefficient of passive. And we also can define the Z critical for active right here, and for the passive we can define how much additional pressure in here. And for the overall pressure definition is slightly different to the cohesionless condition. In the cohesive, we have to consider the cohesion factor, so it's quite lengthy. So I think we'll stop here. So later we can do some exercise. See you again.